Now time has come to start. This is the video number, I think 19th video it is. In between the serial number was disturbed little bit, so I am remembering it is a video number 19 in which we are going to talk about the electric field. What is electric field and its significance we are going to discuss, and also we will be calculating the electric field due to a point charge or a single charge. So electric field defined as a force per unit charge. Force per unit charge. So suppose we force per unit charge, or in mathematically it can be written as electric field E equals to F upon Q, because force per unit charge, it is the scalar form. We can define the electric field. We can write the electric field E equals to, where E is the electric field, F upon Q, force per unit charge. This is a scalar form where we are not using the vectors, but in vector form, if you want to write the same electric field at some given point at some distance r from the origin, can be given by F, which is vector, upon Q, which is scalar, and r cap, where r cap is the unit vector in the direction of position vector r. So these are the two ways in which we can discuss the electric field definition. Electric field in a scalar form, electric field in. Now there are some certain things also which we should know, that this is the new physical quantity which has come to our way, so we want to know more about it. So this is denoted, it's a vector quantity which is denoted by capital E with vector, because, and second one very important, it is a vector quantity. It is a vector quantity, means it has the direction. Okay, later on we will be talking about that, how we will decide the direction of electric field for positive, negative charge, and for combination of two charges, and so on. SI unit is Newton per coulomb. How it is there? Newton, force SI unit is Newton, and charge SI unit is coulomb, so it is a Newton per coulomb also. So Newton per coulomb is the, one more SI unit is that volt per meter. Volt per meter, this definition will come later on to your way, on the basis of this unit has made, that I will be discussing when we will be talking about the Gauss law. Right now it's now, so far what we have discussed, we have defined the electric field. Electric field is a, I am repeating it because I am going to the next, force per unit charge, E equals to F upon Q, or E vector equals to F vector upon Q, r cap. It's a vector quantity. Its SI unit is Newton per coulomb, and its dimension formula easily you can calculate. Okay, now the significance, that what is the significance for us of electric field, or what is the importance for us of knowing about the electric field. Guys, it is just like, suppose if you see there is a inspector of a particular thana, which has a region in which if the crime or something will happen, he will be responsible. Okay, in his area the other something is going to be happen, or maybe peoples are not allowed to do the crime, or if they are going to do, they will pay for it. Similarly, in the physics we can understand the significance of electric field. Suppose there is a charge capital Q, I have tried to show, and suppose its effect is in this area. If effect is in this is the region in which, out of this region, suppose there is no effect. So this is the charge Q which is kept somewhere else, and it is the region in which its effect can be. So who will experience this effect? Some other charge, say Q. But because in definition we have to take the unit charge means 1 coulomb charge. But right now don't focus on the unit charge, just focus on this. Suppose if this charge comes here, or here in this region, definitely it is going to experience some force. Yes, if it is going to be experience some force. Yes, what kind of force it will experience? If it is positive, it will experience the repulsive force. If it is negative, it is positive, then they will be experiencing the attractive force. Means definitely if this charge, some other charge Q, which is trying to come or enter in this region, in any part of this region of capital Q charge, this charge which is trying to come in, okay, will definitely experience a force. Yes, and if this is equals to the 1 coulomb charge, then the force experienced by 1 coulomb charge in the region of this other given charge is called the electric field, and that is given by the formula, that E is the force, how much force is experienced by this charge, and what was the charge. If it is 1, then E will be equals to F, so that the force per unit when Q will become 1, what will be the definition? E will become equals to the F. That's why the definition is made that electric field is nothing, it's a force when the charge is 1 coulomb. Hope you understand. The definition. So this is all about the definition of the electric charge and its significance. Thank you.